When you're looking at distributions of data, I love QQ plots, but histograms also work really well. In particular, if you're not trying to see if the data follows a theoretical distribution, you just want to see what it's showing. A histogram is a great way to do that. If you have bimodal or multimodal data, that will show up in the histogram. If you have skewed data one way or another, right-tailed, left-tailed, that will show up in the histogram. You'd have to choose the exact distribution that you want if you want to use a QQ plot to see if it matches that. So histograms, they're awesome. I love using them to see how your distribution is looking in your data. When we're setting up the code here, the one item we're using this time that's different from our standard for Matplotlib is matplotlib.ticker's max n locator. You'll see why we're using that as we get a little further along in our code. We're using our yearly number of objects launched into space as our data set. We don't need to do too much to prepare this. We're choosing year and yearly launches, grouping by year for those yearly launches, and then we're making sure that the launches are below 2017, because if you recall from an earlier video, after 2017, the launch numbers just started exploding, and that changes the distribution a little bit. So we're choosing before 2017, and then that way the data is all fairly evenly distributed so that it's going to be a little easier to look at. Default histograms in Matplotlib are really simple. Call the histogram, tell the number of bins that you want, boom, you've got an object. This histogram works pretty well. You can see that it's a decent data set. It's more or less unimodal. There are some spikes at the lower end. The lower end is going to be the first few years of the space race when there weren't that many objects being launched, and then the higher end, that's as we're getting a little closer to that 2017 point and people are starting to launch a lot more. But for the most part, you can see that each year is launching around 200 to 300, and this is with 10 bins. But while it works, we can do better. So these are all the changes that I made to that in order to make an even better looking histogram. I chose a slightly different color. I made sure that the title is descriptive to tell a specific story. So the max n locator with integer equals true. The reason I was using this specific spot was to make sure that we are using integers in the scale rather than floats, because it's a little bit easier to read and integers were perfectly usable for what I needed to display. I also called the patches section of the histogram in order to color specific bins a different color from the rest of the histogram, and you'll see what that looks like in the final product. So again, we've got an excellent title here telling you exactly what we're trying to communicate. We have our X and Y axes. In this case, it makes a little more sense to have them as a full out axis, because having to label these individually would actually increase clutter in this situation. And then the color difference, you can see this is highlighting that specific range of what I was talking about in the title of 200 to 350 global launches being the most common numbers that you're seeing. If you want to see more details on how to address the patches of the histogram elements, I'll have that link in the video description. Go check out that video. It was very useful. If you have more questions, please let me know. I look forward to chatting with you in the comments. To the stars!